Hey guys, I'm Jay. Today is my LeetCode review vlog on the 68th problem, text justification. We are given an array of strings, words and a width, max width. We have to format the text such that each line has exactly max width characters and is fully justified. We should pack our words in a greedy approach, that is, pack as many words as you can in each line and pad extra spaces when necessary so that each line has exactly max width characters. Extra spaces between words should be distributed as evenly as possible. If the number of spaces on the line does not divide evenly between words, the empty styles on the left will be assigned more spaces than the slots on the right. For the last line of text, it should be left justified and no extra space is inserted between words. Let's see several examples here. Let's see the second example, what must be, and there are three space between the three words, and acknowledgement as the next word would exceed the length of max width, so the short word would be the third line. So the acknowledgement word is the only word in the second line, so it is be left justified as the problem asked for. And then let's get started with the intuition first. So our intuition to solve the problem is we can break down the solution into a sequence of steps and implement a solution that adheres to the guidelines provided. So there are three steps. The first step, we can call it the greedy construction. The greedy construction. So we'll start by trying to fit as many words as possible on the line until adding another word would exceed the max width. And the second step is space distribution, which means once we have a line's words, we'll distribute spaces to meet the exact max width. The spaces should be as evenly distributed as possible between the words. And the third step is we have to take care of those spatial cases, which is spatial cases. Let's say the last line, or the line with only one word. In those two cases, we don't have to do a fully justified. We only have to do a left justified. And there is no extra space between them. We just add all the space behind the word or behind the last word. And then let's get started with our code right now. So the first step is we can create an string list and each string will stand for each string in the specified line. And then let's get started. So the first step is list string, and let's say justified text, and we are new array list instance. And the second step is we're gonna create a variable. Let's say first word index in each line, and we started at 0. 0 means the first or 0th word in a words list. And we'll have another, let's say a while statement. We have to traverse the words list which is first word index. When first word index is less than or stop length, we have to continue to traverse until the end. And inside the while statement, the first step we are going to check is we have to collect the number of all the characters to see if it exceeded the max width. So we'll create another variable called character number, and it should be initialized at words.first word index dot length, which is the length of the first word. And the second step is we are going to create another variable called the last word index in the current line. Let's say int last word index equals first word index plus 1, and that's the initialized value. And then we'll create another nested while statement, and we have to find the range of words to be included in this current line. We should find the range of words to be included in this line, which is the nested while statement. While last word index is less than word stop length, we'll continue this while loop, and we have to do another additional check, which is if the character nums is exceeded the max width. Let's say words of last word index dot length plus the current character num and plus 1. 1 stands for a space. We have to check if it's exceeded the max width. If the condition is true, we have to do a break. And if the condition is false, we have to append the word. We have to append the length of the word into the character num. Let's say character num plus words of last word index dot length and plus 1, and 1 stands for the space. Oops. And the next step is we have to update the last word index plus plus. So this is all the code inside the while for loop. And then if we got break in the nested while loop, then which means we found all the words in the current line. So our next step is we have to build the line. Let's say build the line. So our first step in to build the line is we'll create a string builder, which is more flexible to append extra string builder. Let's say builder equals new string builder. And the next step is we have to figure out how many gaps between those words. Let's say integer gap equals last word index minus first word index and minus 1. So this is all the gaps between the word in the current line, and we have to distribute spaces evenly as possible in among these gaps. The first step is we'll calculate how many gaps there, and the second step is we have to consider two situations. If this line is a last line, or there's only one word in this line, or there's only one word in this line, we have to do a spatial operation, which is left justified as the problem asks for, and rather than fully justified. And the condition is last word index is equal to words.length, which means this is the last word, or our gap number is equal to 0, which means there's only one word in this line. And inside this condition, all we have to do is append the space as possible as we can. We'll do another for loop int I equals first word index, and the condition is I is less than last word index, and increment I after each iteration. Inside the for loop, we have to append the word and another space. Builder append words of I it should be aside append another space character. So this is the for loop, and out of the for loop we have to delete the character at the last position, which means we have to remove the extra space. And the code is builder dot delete character at builder dot length and -1. And the next step we're gonna do is we have to check if the length of a builder is less than the max width. If so, we have to fill the rest with spaces. While builder dot length is less than max width. If the statement is true, all we have to do is builder dot append the space character, and this is the condition for the last line or the line with only one word. On the other side, except for these two conditions, we have to consider the other lines, and we have to do a fully justified else. So in the second situation, we have to distribute the spaces evenly for each gap as evenly as possible. So our first step is we have to calculate how many space can be distributed evenly and how many extra space remaining. So the first step is we have to calculate the even spaces, which is max width minus character number, and we just divided that gap, and that's the even spaces. And the second step is we have to figure out how many extra space is remaining. and the code is max width minus character number and mod gap. And then we have another for loop, int I equals first word index. Index. And the condition is I is less than last word index, and increment I after each iteration. Inside the for loop, the first step is we have to append the word, and then the second step is we have to calculate spaces to add after each word. So let's get started. Builder dot append words of I, and the second step is we have to calculate spaces for how many spaces to be appended in the after the current word, which is if I is less than last word index minus 1, which means it is now the last word. If it's the last word, we don't have to add any extra space. If it is not the last word, and all we have to do is to handle, and we have to check if there's any extra space that can't be evenly distributed. So let's say integer space to add equals spaces and plus, and we have to do a check if I minus first word index is less than extra space. If the condition is true, which means there is an extra space or 0 space, and then we just add it. We have another for loop, int s equals 0 and s is less than or equal to space to add, and increment s. Inside for loop, we just append space character as much as we need it. And out of the else condition, the left, all we have to do is we have to add the current line to our justified text array or list, which is else is here and a string builder is here. So we have justified text to add builder dot toString, and then we have to update our first word index to the last word index. First word index, so we can continue the while loop. Last word index, and this is the first layer of while loop. And out of the while loop, we just return the justified text as the method asks for, which is a string list. Return justified text, and let's check it out. And then we can analyze. List justify is on line 7. Then we can analyze the time and space complexity. So the time for first word index is on 25th lines, which is first word index. And so our time complexity, it is big O of n, and the n is the total number of characters across all the words, which is the words here. And Each character is processed once when we are check the lines and formatting them. And the space complexity, it is big O of M, and M stands for the number of characters in the output list. This is because in the worst case, each line could be made of only one word and followed by many spaces up to the max width. And yes, our code is got accepted. And thank you guys for watching. This is the end of my LeetCode review vlog on the text justification problem. You can also check for the detailed notes on this problem on my GitHub repository here, and I'll put the link on my YouTube description below. And thank you guys for watching. See you next time.